Hello everyone, this is a first video from a series dedicated to Alias and Dynamo integration. In this session, in this video, I'm going to show you how to create a parametric pattern on a surface extracted from Alias. So I'm going to just select a surface, a front grille of this dataset car. I'm going to go to Edit, Display, and I'm going to hide Unselected. So I'm going to isolate basically the only one surface from this dataset. Let me zoom in a little bit. Then in Alias 2019 we have, if you go to transform, you have this little icon Dynamo. If you click on it, Dynamo will execute and will start running. Okay, so this is also very important that you see this window. If this window disappears, double click once again on Dynamo icon, so you see it. It's also very important part of this, say, Dynamo Alias integration. I'm gonna start a completely new file. The first good thing I'm gonna do is I'm gonna extract the tree called Alias here, and here you can find a node called Select from Alias. Okay, this is the way how I'm gonna communicate Dynamo with Alias. Select from Alias. Select. Dynamo disappears, but it's not. Let's say it's not turned off. It's just minimized. Here I'm gonna select edges. I'm gonna go and select the upper edge of my surface, and I'm gonna hit on Send. Go back to Dynamo, and here, of course, as you could see here, Dynamo tells me one element has been selected. One element selected. If you hover on this little gray area on node, you can see this is the list. Okay, so basically this is what this node is producing, or what this node is taking from Alias as a reference. So as you could see here, however, if I rotate, I don't see anything. That's because Dynamo is unitless, which means that actually if I hit here, you see Dynamo now extracted my curve in a correct position in regard to the coordinate system in Alias, right? So it's just, if this model has been created in centimeters, this curve is so far away from the coordinate system because it's expressed in centimeters. If it was expressed if the model was created in Alias in meters, this curve probably would be much closer to the coordinate system. But this is not a big problem because we can deal with that. There are some nice tools in Dynamo which allow you to feel comfortable and to rotate easily elements which is far away from, and then a piece of geometry which is far away from the coordinate system. So I'm gonna do next. I'm gonna select from Alias again. Select, always edges, and in here I'm gonna select this part, this part, this part, this part, this curve. Okay, let me move here, here, and again, even though I have selected multiple edges, I can do Send, go back to Dynamo, and you can see that my here the script recognizes 5 different curves extracted from the Alias. Then I'm gonna go select from Alias again. I'm gonna select. This time I'm not gonna select edges, but select objects. Okay. Hit on surface, send. Okay, in here I see that Dynamo has selected the upper edge of my surface, the lower edge of my surface, and the surface itself. So I'm going to maximize Dynamo just for the purpose of, again, commodity. If you select, for example, surface, okay, so the surface turns blue. And then if I go to geometry preview and hit zoom to fit, basically what it does is turns, so basically now I'm turning around an element selected. So the gizmo is, so basically it's not rotating around the coordinate system, the original coordinate system, but around the geometry, selected geometry, piece of geometry. Okay, so what I'm gonna do, I'm gonna mirror, because this is obviously just a piece, a half of original surface which has been mirrored. What I'm gonna do next, I'm gonna, if you type in for the node called mirror, okay, you can find that mirrored, so you can mirror, of course, around a plane, right? So what I'm gonna do, I'm gonna find so I have to know which mirror, right? Which plane I need to mirror against. So if I zoom back to my, actually now, yeah, exactly. So this is a little bit difficult right now because I'm far away from the original coordinate system. So what I'm gonna do, I'm gonna just create a little tiny point in the middle, okay, with x, y, z, with its coordinates equal 0. And now if I keep it selected, I go back to the geometry and hit again here. Now I'm back again, and I can rotate in my original coordinate system. So my curves are somewhere there, right? So they are like here. So I know that I have to mirror them against the plane defined by the red arrow and the blue arrow, which means x and z. If I type in x and z, or z zx, so be careful, because here you can find two different nodes. And what I'm interested, actually, because if I select this guy here, I need to provide him some coordinate system. But of course, right now I have one defined, the general one, but I don't have any single coordinate system, so I can connect this node here. So what I need to find is xz. That's a little bit confusing, but this is how it is. And this is the plane, right? So if I go back again to my 5 curves, for example, and I hit on zoom to fit, I'm back again in my geometry. Okay, and what I'm gonna do, I'm gonna keep this plane Z here, and this will probably not be needed anymore, so I can delete that. So I'm gonna take this geometry and mirror. Here it is, right? The next step, the next thing I'm gonna do, I'm gonna take this, just Control C, Control V, copy, and mirror these guys here. So I have right now one piece of geometry and the second piece of geometry mirrored. Okay, so, but what I need to do, I want to make this curve, the upper edge of the surface, one single curve. I need to turn the set of curves into polycurve. So I'm gonna just join them. Okay, let's join. Now take this guy here, take this guy here. So I have two curves, one and second. Another thing you can do, actually, to help yourself understand, what makes a little more clear what you're actually selecting, is because if I select this, you see that these curves are overlapping. There are several curves from, let's say that this is the first curve, right? This is the second curve, and then I have joined them together, and still all of these curves are being visualized. Okay, so what I can do is I can hit on the node, I can right click on my mouse and turn off the preview, and do the same here, turn off the preview. Okay, so now I see the graphics shows me only these elements which are basically turned on. So I'm gonna take these curves and I'm gonna use polycurve by joint curves, right? So I'm gonna turn this and I'm gonna turn it into a one single element. Again, turn off the preview. Okay, I have one curve. Now I'm gonna do the same here below. So I'm gonna just copy and paste again, list join. I'm gonna take my 3 curves, take this here, turn off, and join again. Please note that the curve disappeared, right? So because of course no, sorry, it doesn't appear because it's turned on here. So now I don't see any curve, they're all turned off. But now I can take this and I have one single polycurve out of my NURBS curves selected from Alias. Okay, so what I'm going to do next, I will create some points which will be located at this curve, and you have a node called point at parameter. What it means, parameter means that if you think about the curve, a curve, every curve, it doesn't matter how long it is. Okay, it can be 1 centimeter and 5 kilometers. We don't care. But the beginning is always parameter 0, and the end of the curve is always 1, which means that if I by default the default value is 0, right? So by default I got the point at the very beginning of my curve. If I type in 0.5 and you see that I have this point in the middle. So everything between 0 and 1, every fraction between 0 and 1 is a point somewhere on this curve. Okay, so in order to create a list of numbers which will represent parameters between 0 and 1, what I need to do, I need to create a series of numbers. One of the methods of creating a series of numbers in Dynamo is to use a language which basically works under the hood of Dynamo, and this language is called design script. So according to design script, if you type 0 and then or from 0 to 1, so I'm defining first, let's say the one border and the second border, the start and the beginning. So from 0 to 1, and then another 2 dots, hash, let's say 30. This gives me a list of numbers from 0 to 1, okay? And I have 30 numbers from 0 to 1. These 30 numbers can be turned into points, okay? Between beginning and the end of the curve. There are, if you're more interested how to create, how to generate other types of list of numbers, please go to help, samples, and have a look on I think it's here, as far as I remember, code blocks. It should be there. Okay, so basically here in this help you'll find some other references how to use design script in order to create a list of numbers. Okay, so I'm gonna do similar thing below. Okay, now please make sure that the order, the beginning and the end of these series of points are, let's say, so let's make sure that the first point on the upper edge is also the first. So basically, on the lower edge we also have this point as first and not as last. So if you type in here, if you hit on the icon on the node and hit here, show labels. Okay, so I see that this is my first, second. Okay, so this is the first point and the last point is over there. If I do the same here, show labels, I see that for some reasons of basically for the sake of selection of how I have selected the points from my basically from Alias. Remember that first I selected this curve, then I selected this curve, then I selected this curve. Okay, so basically this created a situation in which basically at the end, when I joined this curves, at the end they have the direction have been reversed. But if I had selected this little piece first and this then again, okay, and then I say, so basically if this will be in this following order, then I wouldn't have this problem, the situation now that the upper row starts with 0 and the lower starts with 0 here, and the lower row of points starts actually there. But what I can do here is actually I can go and say, okay, I want to reverse. Okay, and if I reverse either, it doesn't matter. If I reverse I can do actually two things here, because either I can reverse a list of points. Okay, now I see they both start from the same side. Okay, so I just basically reverse this list. So my original list, this point was the first one, and this was the last one, and basically now this list is absolutely reversed, right? So basically the last point here is now the first on this list, right? What I could also do actually is, if I'm gonna turn it on again, what I could also do actually, I could also reverse a curve. Actually the result will be absolutely the same. Okay, Just takes the curves and reverses the direction of the curve. Of a curve. Okay, but let's use this list reverse. Now, what I'm gonna do, I'm gonna create a, okay, I want to create a line, okay? Line, in order to, let's later on start the pattern. But however, as you could see here, this is, my curve of course is, my surface is not, you know, straight planar surface. It's of course, it's a trimmed surface taken from Alias, which has pretty complicated topology. Complex topology. So what I'm gonna do, instead of using turn this off. Instead of using lines, I'm gonna first, you have, if you look for the nodes, what you have here is a curve, and you can create a curve on a surface using the start parameter and end parameter, right? As I told you, like parameters on a curve so basically surface work in a very similar way like curves. So if I want to create, I don't know, I want to create a point on in the middle of the surface of our surface here, from here, what I need to do is of course, sorry, because just that's this node does a little bit different thing. So what I need this node, surface point at parameter, right? So if I take my surface and provide 0, 5 and 0, 5, of course it will create me a point in the middle, right? So what I need to do in order to create curves which will go from here to here and they follow the topology of the surface, what I need to do actually is to find what parameters, like which parameters represent these points on this surface in basically in the location where they are. Okay, so if I look for the node called UV, and this is UV parameter at point, surface UV parameter at point. So what it does is it's asking me for the point. Okay, I'm gonna give him a point, surface. Okay, and what it does, it gives me a series of parameters of these points on the surface. Okay, so of course this point, the parameter of this point on this surface is 0, 1, right? U0, V1, and then, but the funny thing is that this point, of course, does not have a the parameter. Let's say if this one has 0 and 1, this doesn't have 1, 1. You'll see it in a moment. So this point has a little bit different parameters, as 0 and 0 and 0.38, right? 308. This is due because of the fact that this surface has been trimmed in Alias. Okay, because again, if I go back to my point at parameter node, and if I create again, let me use the same series of numbers, right? I'm gonna create this and this lacing cross product, so I create a U times V basically. So you could see that of course the topology, the original topology of the surface is basically like this, and once it's trimmed, of course let's say that these points will go beyond the surface. Okay, so that's why I needed to find the UVs, so the parameters of this point of the surface. Okay, so what I'm gonna do next, I'm gonna take my base surface, so this is gonna my start parameter and this is gonna my end parameter. What it does, of course, it creates me a series of curves which follow basically the topology of my surface, right? Curves which follow the topology of the surface. Okay, let me show you one more thing regarding which is related to design script. Okay, what I'm gonna do next, as you could see here, this number of course can be increased like to 40, and then of course I increase the number of surfaces of curves on my surface. But let me think that, so let's imagine that we want to have some to have a possibility to provide this number in a more flexible way, okay, instead of 40 typing in here. But basically what I can do, I can search for slider, okay, integer slider, okay. I'm gonna provide him a number of let's say a series of, I'm gonna provide him a as you could see some certain number, okay, but of course now I want to specify that number of these curves has to vary between, let's say, 10 and 50, okay. And now, so I'm basically in the range of between 10 and 50. So if I, instead of having 40 here, I type simply n, like number, okay, this becomes a number. If it's not if it's not a number but a string, a letter, then this n number turns to be a variable and jumps in the front of a code block, okay. And by the way, if I didn't mention it before, to call a code block, you just double click on the canvas, okay. So if I connect this here, now as you could see here, I don't have to type in manually the number, okay. So let's keep maybe 30 for the moment. Okay, so now we have created something on the surface. Let's, of course, I'm doing something here, and in Alias I don't see anything yet. So let me bake it to Alias. So let me bring this curve into Alias. It tells workspace must be saved on disk. All right, so let's save it. I'm gonna save it on my desktop as part 1 of the video. Save. Okay, I have 30 curves baked to Alias, but here they are. Right? Let me increase the number of. Let me maybe put it aside, and let me. So I see my slider, and if you increase, hop, this will also increase in Alias, right? Okay, let's close this video at this time, so the videos will not be too long, and see you next video.